Hello, in this video, I am going to show you how process engineers can use CSense to avoid product quality defects. This is the CSense discrete and batch troubleshooter. Since this is a discrete process, I am using this to connect to our historian and load in historical data for our process from our historian time series sensor data recorded over time for the parts that's being manufactured. Then I can also connect easily to our laboratory information system and load quality data for the different parts that we manufacture, whether it was good or a defect. With the CSense troubleshooter, I can easily combine the data for analysis and provide the necessary process context, like the fact that the output or the target variable that I want to analyze is the defect. We are also manufacturing different engine parts on various machines using various tools called cavities. We are doing that by managing and adjusting several process variables that we can control and adjust to produce good quality engine parts. Once I have done that, I can analyze this data using the CSense discrete and batch troubleshooter and with the decision tree machine learning technique. I can check why we are making poor visual defects. I can select the input and the output variables to create the decision tree model. In this case, my dataset summarized that we have made 26,000 parts and we have 1.3% poor visual defects that I need to find why. I can check in CSense troubleshooter why. By doing that, it ranks all the process inputs based on the ones that can best explain the difference between good and bad products. In this case, it is saying that the combination of cavity, mission name, and part can best explain why we have poor visual defects. I am going to split and further drill deeper based on part. It identifies that if we are making this part, our risk of defect is much higher than making the other parts. Drilling deeper into that, the next most important in determining defect rate when we are making that specific part is something called FT, which I will drill deeper into. And here I can see that if FT or final temperature is higher than 70, we are having a worse defect rate, and if it is below 70, we have an improved defect rate. I will drill into that. Next is an adjustable variable called RTVL. I am going to drill into that. Here I make my first discovery that when we make this part, if we can keep FT below 70 and RTVL above 357, we will have the lowest possible defect rate for that part. Let us look into the other parts and check why we are making defects. It highlights that the parameter called BLOFF, when I split on that, I identify that on this condition, if we can keep the BLOFF below 18.53, then we can avoid most of the defects when we are making these parts. In this way, CSense Troubleshooter can help you identify conditions which will provide the best product quality and help avoid poor visual defects when making these kind of engine parts in the future. I can now deploy these rules that CSense Troubleshooter helped us to identify and save them into CSense Architect. I can deploy the analytics using CSense Runtime Manager to permanently advise my operators on how to avoid product defects. Here in the scripting environment, I can embed and implement the rules that CSense identified. For example, for part 6808, keeping the FT less than 70 degrees and RTVL greater than 357 degrees will help us to avoid poor visual defects. This analytic can now be deployed to permanently run in the CSense Runtime Manager, reading inputs from available control systems and other systems through OPC in real time, and writing recommendations out through OPC, publishing it to external systems so our automation systems like DCS or SCADA can display the operator recommendations. Here is an example where Matricon OPC client is displaying the recommendations that CSense is publishing. You can see that for every part that is made, CSense is publishing appropriate recommendations to the operators on how to avoid poor visual defects on that specific part. In this video, I showed you how process engineers can use CSense to avoid product quality defects. Thanks for watching.